Hello student, on behalf of Silicon classes, we will study topic today, acids, bases and salts. We will cover the definition of acids and bases, general properties of acids and bases, acidity and basicity, neutralization, examples and uses, pH scale, indicators and its types, importance of pH in everyday life, definition and classification and pH of salt, and preparation uses of some compound like sodium hydroxide, bleaching powder, baking soda, washing soda, and plaster of Paris. Now I am coming in definition. Acid. An acid is a compound which, when dissolved in water, yield hydronium ions as the only positively charged ions. You just see the reaction. Suppose HCl, when reacts with water or dissociates in water, it will form hydronium ions and Cl minus, that is chloride ion. So HCl is producing the hydronium ions in its water solution. So it is called an acid. Any compound which in its aqueous solution will form, if formed, hydronium ions, then this compound is called the acid. And what is the base? A base is a compound which reacts with hydronium ions of an acid to keep salt and water. It produces hydroxyl ions as the only negatively charged ions when dissolved in water. A base is a compound which dissociates to form the hydroxyl ions. Suppose NaOH, Na plus OH minus. So sodium hydroxide is dissociates to form hydroxide ion. So sodium hydroxide is base. So any compound, a compound which dissociates to form hydroxide ion, then it will be called the base. What are the properties of acids? Number one, physical properties. It is sour. Mineral acids are highly corrosive. It turns blue to litmus red. Reaction with metal. The acid reacts with active metal, liberates with hydrogen. For example, suppose zinc, when reacts with HCl, it will form zinc chloride plus hydrogen. So zinc is a metal while reacts with HCl will form the hydrogen. It will liberate the hydrogen gas. Then we are coming another properties of acid, that is when it reacts with carbonate and bicarbonates, it will form the carbon dioxide, water and corresponding salt. For example, suppose HCl while reacts with sodium bicarbonate, it will form NaCl plus H2O, water and carbon dioxide. Actually, it will form the carbonic acid but carbonic acid is a very weak acid. It will dissociate to form water and carbon dioxide. So, HCl, that is hydrochloric acid, while reacts with sodium bicarbonate, form carbon dioxide, water, and corresponding salt. Similarly, when HCl reacts with sodium carbonate, it will form same salt, water, and carbon dioxide. Next, while the acid reacts with bases, it forms salt and water. For example, suppose nitric acid, while reacts with potassium hydroxide, it will form potassium nitrate plus water. Reaction with metallic oxide. Acid reacts with metallic oxide to form salt and water. Suppose, for example, metallic oxide is CuO, while reacts with acid to form corresponding salt, that is CuCl2 plus water. This is cupric chloride. The acid reacts with chloride and nitrates of less volatile. The less volatile acid, while reacts with more volatile, the chloride and nitrate of more volatile acids, it will displace the more volatile acids on heating. What is the example? What is the reaction? Suppose less volatile acid is sulfuric acid, while it will react with more volatile, that is more chloride or nitrate of more volatile acid, that is NaCl. HCl is a more volatile acid and its corresponding salt is sodium chloride. So while sodium chloride reacts with sulfuric acid, it will displace the more volatile acid and form the corresponding salt of less volatile acid. Similarly, the less volatile acid, that is sulfuric acid, while reacts with salt of more volatile acid, it will displace the more volatile acid and salt of less volatile acid. Now, we are coming the properties of bases. Base reacts with non-metallic oxide to form salt and water. For example, non-metallic oxide is CO2, carbon dioxide, while reacts with NaOH, it will form Na2CO3 plus H. While the base reacts with ammonium salt, on heating, it will liberate ammonia. Suppose ammonium salt is ammonium chloride, while reacts with NaOH, it will form corresponding salt NaCl plus water and will liberate ammonia gas. Here, the base reacts with metallic salt to form to precipitate insoluble hydroxide. What is metallic salt? Suppose CuCl2, while reacts with NaOH, it will form CuOH whole 2 plus NaCl. This is the blue colored precipitate. Insoluble in water. So while the metallic salt, that is cupric chloride, reacts with the base, it will precipitate. It will form a precipitate of metallic hydroxide and will form the corresponding salt. The less volatile bases reacts with chloride or nitrate. The less volatile bases reacts with fluoride or nitrate or more volatile bases to displace more volatile bases on heating. What is the less volatile bases? Suppose sodium chloride, sorry, sodium hydroxide, and salt of less volatile basis. This is more volatile. Now we are coming the acidity and basicity. Basicity of acids. It is nothing but the number of hydrogen ions which can be produced per molecule of the acid in aqueous solution. And what is the acidity of base? The number of hydroxyl ions which can be produced per molecule on the base in aqueous solution. Now we are coming. Suppose for HCl, it will form one number of one H plus ion. So it will be called the monobasic acid. Sulfuric acid. It will form two number of H plus ion. So it will be called dibasic acid. Phosphoric acid. It will form 3H plus ion. So it is called tribasic acid. So while an acid will form single hydrogen ion, it will call the monobasic acid. While it will form the two hydrogen ions, it will be called dibasic acid. While it will form the three hydrogen ions, it will be called the tribasic acid. So this is the basicity of acid. So this H plus ion will react the OH minus ion while an acid and base reacts with each other. Similarly, the basicity of acid, the acidity of base is nothing but the number of hydroxide ion produces. But this the number of hydroxide ion produces when a base will dissociate. For example, NaOH, while it will dissociate to form one hydroxide ion, so it is monoacidic base. Copper hydroxide, it will form two hydroxide ion, so it will be called diacidic base. Aluminium hydroxide, it will form three number hydroxide ion, so it is called triacidic base. So these are the example of mono, di and tribasic acid, mono, di and triacidic base. Now we are coming the neutralization. Yes. The process due to which hydrogen ions of an acid react completely to combine with hydroxyl ions of a base to give salts and water only. During neutralization, the hydrogen ion or proton from the acid is neutralized by the hydroxyl ions from the base to form a water molecule. This is the exothermic reaction. Heat will be produced. The amount of heat liberated when 1 gram equivalent of an acid or base is completely neutralized. Now we are coming in the reaction. How an acid and base will react. Suppose HCl reacts with NaOH, it will form corresponding salt and water. How it will dissociate? HCl. It will dissociate to form Cl minus. NaOH. It will dissociate to form hydroxide ion and Na plus. While it will react HCl plus NaOH. These two reacts with each other to form water plus NaCl plus heat. So this is the classical example of a neutralization reaction. These are some uses of acids and bases. Number one, eye wash. Boric acid is being used as eye wash in cooking acetic acid, as food preservation citric acid, ink stain remover oxalic acid, flavoring drinks carbonic acid, baking powder tartaric acid, pickling of metals hydrochloric acid. Bases. Manufacturing of soap NaOH, manufacturing of bleaching powder calcium hydroxide, antacid magnesium hydroxide, fire extinguisher aluminum hydroxide, softening water calcium hydroxide, removing grease stains ammonium hydroxide. So these are some uses of acids and bases. Now we are coming the pH scale. So pH scale, pH is defined as the negative logarithm to the base 10 of the hydrogen ion concentration expressed in moles per liter. Suppose pH, sorry, sorry, pH is nothing but this is the equation of pH. Logarithm, logarithm of concentration of H plus, logarithm of base 10. This is the equation of negative logarithm of concentration of H. pH equal to minus log base 10 concentration of H plus. So pH is the scale from 0 to 14. In middle it is 7. pH greater than 7 is basic. pH less than 7 is acidic. 7 is neutral. So pH is the scale. It is from 0 to 14. 7 is the neutral. From 0 to 7 it is acidic. And from 7 more than 7 to 14 is basic. The pH value represents the strength of acids and bases expressed in terms of hydrogen ion concentration. And this is the equation, whatever I have told in earlier. pH equal to negative logarithm of base 10 of concentration of H plus. Now we are coming to indicators and its type. Indicators are weak organic compounds, acid or bases, which changes color in accordance with the pH of the solution. Number 2. Indicators dissociate slightly in solution, producing ions and undissociated molecules. The color of the ions produced is dependent on the hydrogen ion concentration or pH of the medium. There are two types of indicators, A. Common acid-base indicator and B. Universal indicator. Common acid-base indicators. Examples: litmus, methyl orange, phenolphthalein, etc. The common acid-base indicators. Suppose in litmus, it will show while it will show it will turn red while it is in contact with the acidic solution, and the basic solution turns the litmus to blue. So, what are the utilities of common acid-base indicators? These are some points. Number A, it indicates whether solution is acidic or alkaline. B, it cannot be utilized for determining the strength of the acidic or alkaline solution. C, it cannot differentiate between the acidic or basic solution of different pH values, since they change their colors abruptly at a certain pH value. Now we are coming in universal indicators. Example: It is mixture of organic dyes or mixed indicators, example pH paper or solution. What are their utilities? A. It indicates the strength or pH range of the acidic or alkaline solution. It can be utilized for determining the strength of acidic or alkaline solution. Whatever I have told for common acid-base indicators, they cannot be utilized for determining the strength, but universal indicators can be utilized for determining the strength of acidic or alkaline solution. It can differentiate between acidic or basic solution of different pH values by giving different colors with different pH values. What are the importance? There are some points I have to state. Number one, plants and elements are pH sensitive. Our body works within pH range of 7 to 7.8. When pH of rainwater is less than 5.6, it is called acid rain. When acid rain flows into the rivers, it lowers the pH of the river water. The survival of aquatic life in such rivers become difficult. Number two, pH of the soil. Plants require a specific pH range for their healthy growth. C. pH in our digestive system. Our stomach produces hydrochloric acid, which helps in the digestion of food without harming the food. During indigestion, the stomach produces too much acid, and this causes pain and irritation. To get rid of this pain, people use bases called antacids. These antacids neutralize the excess acid. Magnesium hydroxide, that is milk of magnesia, a mild base, is often used for this purpose. Number four, pH change as the cause of tooth decay. Tooth decay starts when the pH of the mouth is lower than 5.5. Tooth enamel made up of calcium hydroxyapatite, that is a crystalline form of calcium phosphate, is the hardest substance in the body. It does not dissolve in water but is corroded when the pH in the mouth is below 5.5. Bacteria present in the mouth produce acids by degradation of sugar and food particles remaining in the mouth after eating. The best way to prevent this to clean the mouth after eating food. Using toothpaste, which are generally basic for cleaning the teeth, can neutralize the excess acid and prevent tooth decay. Number five, self-defense by animal and plant through chemical warfare. Visiting, visiting leaves and acid which causes pain and irritation. Use of a mild base like baking soda on the stung area gives relief. Stinging hair of nettle leaves inject methanolic acid causing burning pain. Now we are coming to the salts. Definition. A salt is a compound formed by a partial or complete replacement of the replaceable or ionizable hydrogen ion of an acid by a metallic ion or ammonium ion. How salt is formed? Suppose NS, sorry, Na, which is the base, while it will react with sulfuric acid, that is an acid, will form NaHSO4 plus water. Here in sulfuric acid there are two replaceable hydrogen. Here sodium hydroxide, that is hydroxide ion, replace one of the hydrogen atom and it will form the sodium bisulfate and water. This sodium bisulfate is again reacts with sodium hydroxide to form sodium sulfate plus. So the salt is formed while acid reacts with bases and the replaceable hydrogen atom of an acid will be replaced by hydroxide ion of a basis partially or fully. Here, hydrogen atom is partially replaced to form sodium bisulfate. And here, the hydrogen ion of sulfuric acid is being fully replaced by hydroxide ion to form a common salt. There are mainly three types of salt, like acid salt. It is formed by partial replacement of the replaceable hydrogen ion of an acid molecule by a basic radical. Here, sodium sulfate bisulfate is being formed by partial replacement of the hydrogen ion of sulfuric acid by hydroxide ion of sodium hydroxide. So it is called the acid salt. Number two, normal salt. It is formed by complete replacement of the replaceable hydrogen ion of an acid molecule by a basic radical. Sodium sulfate. Here, all the replaceable hydrogen ion, of sulfuric acid are being replaced by the hydroxide ion of the sodium hydroxide. So this is the common salt. Another one is the basic salt. It is formed by partial replacement of hydroxyl radicals of a diacetic or triacetic base with an acidic. For example, suppose CuOH whole. This is the diacidic base. Already we have studied in earlier slide. While it will react with HCl, it will form CuCl plus water. This is called the basic salt, where only one hydroxide ion out of two hydroxide ion present in copper hydroxide has been replaced by H plus ion of Cl minus, a hydrochloric acid, to form the basic salt. Now, some preparation from the common salts. Some raw materials have been prepared from the common salt, which are mentioned in this slide. Sodium hydroxide. It will form by reaction with sodium chloride and water to form sodium hydroxide. Bleaching powder. In the reaction number one, the chlorine is formed by reaction of sodium chloride and water. This chlorine will react with calcium hydroxide to form calcium hypochlorite. It is the bleaching powder. Baking soda. Sodium chloride while reacts with water, carbon dioxide, and ammonia to form sodium bicarbonate and NaCl. It is the baking soda, sodium tricarbonate. Washing soda. Sodium chloride, sodium chloride, washing soda. Sodium carbonate dot NH2. This is the formula of washing soda. Plaster of Paris. Calcium sulfate. This is the formula. This is the formula of plaster of Paris. Now we are coming the uses. Bleaching powder is being used for bleaching cotton and linen in the textile industry, for bleaching wood pulp in paper factories, and for bleaching wash process in laundry. Number two, as an oxidizing agent in many chemical industries. And number three, to make drinking water free from germs. Baking soda is used as one for making baking powder, which is a mixture of baking soda, that is sodium hydrogen carbonate, and a mild edible acid such as tartaric acid. When baking powder is heated or mixed in water, baking powder is heated or mixed in water, the following reaction takes place. Sodium bicarbonate and hydronium ion by hydrogen ion from any acid. It will form carbon dioxide, water, and sodium salt of acid. Carbon dioxide produced during the reaction can cause bread and cake to rise, making them soft and spongy. Number two, sodium hydrogen carbonate is also an ingredient in antacids. Being alkaline, it neutralizes excess acid in the stomach and provides relief. Number three, it is also used in soda acid fire extinguishers. Washing soda. Sodium carbonate, that is washing soda, is used in glass, soap, and paper industries. Number two, it is used for decoration purpose. It is used for making surfaces sponge. So these are the topics of acid bases mainly studied in class 10 at Cbse, but it will be helpful for the students of other boards also. If you will like this video, if it is helpful for your study, then please like, share, and subscribe. And if any queries, you may send an email to this email ID siliconclasses24 gmail.com. So thanks a lot, and I shall come with another chapter. I think it will also be helpful to you. Thank you very much.